Hello students, myself Dr. Mansoor Maulavi, PDA's Professor Ramkrishna More College, Akurdi, Pune. Today we will learn about the conformational isomerism concept and the conformation of ethane. Conformation of ethane is the most easy way to understand the conformational isomerism. Conformational isomerism is a type of stereoisomerism that arises due to the rotation about the carbon-carbon single bond. That rotation about the carbon-carbon single bond shows the different positions or arrangement of groups around the carbon atom. For example, molecular modeling, we can see the rotation about the carbon-carbon single bond like this. At room temperature, the carbon-carbon single bond undergoes rotation and that shows the different positions. And because of that different positions of arrangement of groups around the carbon atom, the energy of molecule also changes. So the isomerism that arises due to the rotation about the carbon-carbon single bond is known as the conformational isomerism. Rotation about the carbon-carbon single bond is possible, and that rotation shows the different position or arrangement of groups around the carbon atom. We have examples: staggered and the eclipse conformation of ethane, chair and the boat conformation of cyclohexane, anti and syn conformation of butane are the examples of the conformation to understand the conformational isomerism. Different positions of atoms or group in a molecule are obtained due to the rotation about the carbon-carbon single bond, and that different positions is known as the conformations or conformational isomer. The examples of the conformational isomers are staggered, eclipse, anti-syn conformation, chair or boat conformation in the cyclohexane. Description of the conformation. The conformation are nothing but the different position of the same molecule. In same molecule, the carbon-carbon single bond undergoes the rotation that gives different position, and that different positions are nothing but the conformation or conformational isomers. And that conformational isomers can be described by using the projection. These projections are nothing but the way of arranging the molecule to visualize the conformation. First way is the Sawhorse notation. Sawhorse notation or projection. In this, the carbon-carbon bond is placed or drawn diagonally so that both carbon atoms and all their attached groups are clearly visible in three-dimensional manner. The second projection is Newman projection formula. The Newman projection formula represents the molecule viewed directly along the axis of carbon-carbon single bond. Whenever we arrange the molecule along the axis of carbon-carbon single bond in front of our eye, then that projection is known as the Newman projection. This is the Newman projection. This is the Sawhorse notation. In this carbon-carbon single bond of a molecule is arranged diagonally. In the Newman projection formula, the carbon-carbon single bond is placed axis to axis in front of our eye. This front carbon is shown by the dot. This back carbon is shown by the spear. This is front carbon, back carbon is spear carbon. This is the Newman projection formula. In the molecular modeling, we will show both the formulas. This is formula, that is Sawhorse notation. In the Sawhorse notation, the carbon-carbon bond is placed diagonally, and whenever we place that carbon-carbon single bond along the axis in front of our eye, then this is known as the Newman projection formula. We can rotate the carbon-carbon single bond, and that carbon-carbon single bond rotation gives the different position of atoms or group around the carbon atom, that is known as the conformations. The third way for the description of the conformation is the dihedral angle. Dihedral angle is nothing but the angle between non-bonded groups around the adjacent carbon atom in space is dihedral angle. Because of change in dihedral angle, the potential energy of the molecule changes. That non-bonded groups on a carbon shows different interactions like electronic interaction, steric interaction in the space. That interaction leads to change the potential energy of the molecule. So whenever we view the molecule along the axis, that is the in Newman projection formula, then these two hydrogens are non-bonded hydrogens, and that non-bonded hydrogens interact. The angle between that non-bonded hydrogens around the bonded carbon atom is the dihedral angle, and because of interaction of that non-bonded groups, it shows the steric interaction, it shows the electronic interaction. So because of that interaction, the potential energy of molecule changes. So in the conformational isomerism, molecule can be described by Newman projection formula, Sawhorst notation, dihedral angle, and the potential energy. So with this knowledge, we are moving ahead. The conformation of ethane. In the conformation of ethane, this is the molecular formula ethane. It contains 2 carbon and 6 hydrogen. This is the structural formula. CH3, CH3. Each carbon possesses the 3 hydrogens. So when we rotate the carbon-carbon single bond of a ethane by the interval of 60 degree, then we observe the 2 types of conformation. First conformation is a staggered conformation, and second conformation is the eclipse conformation. In the eclipse conformation, all the non-bonded hydrogens are eclipsing to each other. The second conformation is a staggered conformation. In the staggered conformation, all the non-bonded hydrogens are away from each other. Conformation of ethane, in which all the non-bonded hydrogens are eclipsing to each other, are known as the eclipse conformation. The conformation of ethane, in which all the non-bonded hydrogens are away from each other, is known as the staggered conformation. We will look both the conformation by using Sawhorst notation and the Newman projection formula, and we will look how the potential energy of a conformation changes with the dihedral angle. This is the Sawhorst notation. These are the non-bonded hydrogen present on in each carbon. So in Newman projection, we found that this hydrogen is eclipsing or covering this hydrogen. It shows the electronic and steric interaction. So accordingly, in Newman projection formula of eclipse conformation of ethane, it shows 3 hydrogen interaction. The energy of one hydrogen interaction in the conformation is about 1 kilocalorie per mole. So for 3 hydrogen interaction, it becomes 3 kilocalorie per mole. The potential energy of a eclipsing conformation of ethane is 3 kilocalorie per mole. This eclipsing conformation we observed at 0 degree, 120 degree, and the 240 degree. Second conformation is a staggered conformation. In the Sawhorst notation for the staggered conformation of ethane, we observed that all the non-bonded hydrogen on each carbon are going away from each other, leading for the minimization of all the hydrogen of interaction. The energy of the staggered conformation of ethane is 0 kilocalorie. The staggered conformation is observed at 60 degree, 180 degree, and the 300 degree. So in the molecular modeling, we will observe that how the energy of the molecule changes So this is the Newman projection formula for the eclipse conformation of the, it is observed at the 0 degree. So by 60 degree, we are changing the position. So this is 60 degree dihedral angle. At 0 degree, we observed the eclipse conformation. At 60 degree, we observed the staggered conformation. Again, at 120 degree, we observed the eclipse conformation. At 180 degree, we observed the staggered conformation. So we observed that with rotation or with change in dihedral angle, the energy of molecule changes. At different dihedral angle, molecule shows different types of electronic and the size interaction that leads to the change in energy. So I observed that the energy of eclipse conformation is more or higher than the energy of the staggered conformation. So with this eclipse conformation and the staggered conformation of ethane, we move forward energy and the stability of the conformation. Eclipse conformation contains the steric interaction and the electronic interaction of 3 hydrogens. So its energy is 3 kilocalorie per mole. Eclipse conformation is observed at the 0 degree, 120 degree, 240 degree, and the 360 degree. Staggered conformations, all the non-bonded hydrogens are going from each other, so its energy decreases. The energy of staggered conformation of ethane is relatively lower or smaller than the eclipse conformation because of absence of all the interaction. Accordingly, the energy of staggered conformation of ethane is 0 kilocalorie per mole. The energy of eclipse conformation of ethane is 3 kilocalorie per mole. So if we comment on the stability, then we observe that staggered conformation of ethane is more stable than the eclipse conformation because of the energy. So ethane molecule shows two type of conformation: eclipse conformation and the staggered conformation. Eclipse conformation of the ethane is less stable than the staggered conformation of ethane. Thank you.